Hi everybody, this is part 3 in a series of solving quadratic inequalities. Now if you've never solved any quadratic inequalities, I'd recommend watching part 1 and part 2 where we looked at some more information for why the procedure works where we're doing this. So first thing you want to do when you solve a quadratic inequality is get 0 on one side. So in this case I'm going to bring everything over on the left. I want to know where 7.34x squared minus 16.55x minus 3.89. I want to know where that's greater than 0. So notice I have a quadratic equation here on the left hand side, a quadratic expression. I want to know where it's greater than 0. In order to do that, I first need to identify the critical values, and the critical values are actually the solutions of the associated quadratic equation. So I'm going to go ahead and solve where 7.34x squared minus 16.55x minus 3.89 equals 0. Now in the previous examples we're able to just factor this, and that's really the significance of this example. It's not easily factorable, but I'm still want to find the critical values by just setting it equal to 0 and finding what those are. So I can do that fairly easily on my graphing calculator. I have a program here that will quickly tell me the decimal values, and since this is in decimals that'll work just fine. So my A value is 7.34 and my B value is a negative 16.55 and my C value is a negative 3.89. Okay, so I know that my critical values are going to be about 2.47. Let's just round to the nearest hundredth here. So x equals 2.47, or maybe I'll use a wavy equal sign. It's not quite exactly that. And what was the other one about negative 0.21? All right, so those are the values. If I were to graph this quadratic equation, y equals that, I know there'd be x-intercepts at these points. So this would be about negative 0.21 and 2.47. All right, and then what I need to do is determine the intervals that are determined by those critical values. So I have this interval from minus infinity to minus 0.21, and then I have another interval from minus 0.21 to 2.47, and then another interval from 2.47 to infinity. And I want to test those intervals. I want to choose a point out of each interval, like right here. Something to the left of negative 0.21 would be like negative 1. If I were to plug in say 0, 0 would be between negative 0.21 and 2.47, and in this interval I could plug in 3. Now, I'm not going to be able to plug those in very easily in my head, so let's go ahead and go to my calculator here, and let's put in here the 7.34 x squared minus the 16.55x and the minus 3.89. Okay, and I'm going to go to my table setup here. I'm going to put my independent variable on ask, and then I can just put in whatever x value I want, and I'll go to my table, and if I plug in negative 1, I'm going to get 20. Alright, so if I plug in negative 1 here, I get 20, and in particular that tells me that if I plug in negative 1, I get something positive. Alright, and if I plug in 0, I can actually plug 0 in here. That's easy. And 0, 0, I'm going to get negative 3.89. That's going to be something negative. And the other one I want to plug in here is 3. So if I plug in 3 here, I'm going to get 12.52. Let me just plug in 0 while I'm there so you see it really is negative 3.89. So if I plug in 3, I get 12.52. And again, all I really care about is that it's positive, because I want to know, right, I'm plugging them into this expression right here, and I want to know where is that expression greater than 0. Greater than 0 means something like 20 or 12.52, or in particular just something that's positive. So my answer here is going to be the interval. Anything in this interval is going to make it true, makes it positive, greater than 0. Anything in this interval makes it true, makes it positive or greater than 0. So my answer is going to be the interval from minus infinity to negative 0.21 union from 2.47 to infinity, realizing that those are rounded to the nearest hundredth there. All right, so we might also notice, because this was a quadratic inequality, and these points right here are the x-intercepts, even without plugging in any points, I know that because this is quadratic and the leading coefficient is positive, it has to be opening upward. So I should have in mind that the graph looks something like this. Right? And just from that graph, I want to know, I'm ultimately trying to figure out where is that graph greater than 0. And you can see it's going to be greater than 0 here and here. That corresponds to these x values, right? Over here and over here. Any of these x values are going to make the graph be above the x-axis. All right, so if I were to graph the associated quadratic function on my graphing calculator, so I already have that plugged in here. If I just graph zoom 6 there, you can see it looks like this, and you can go ahead and find the zeros, and you'll see that one crosses the x-axis. Let me show you real quick how to do that. If you've never seen that before, you calculate the 0, and then you give it a left bound. You have to go on the left-hand side of the 0, so negative 0.42, the x value, is less than the negative 0.21 that is the actual 0. I hit enter, and then I arrow over on the right-hand side and hit enter. Then I arrow over here kind of close to where it is. Notice that this isn't exactly the 0 because my y isn't 0. If I hit enter, sure enough, it does tell me the 0 is that. And I could also find this other 0 the same way. When I do that, when I get the 2.469, that's what we got. The y value here says negative 1 times 10 to the negative 12. So we understand that 0. In fact, that's just round off error from the way your calculator computes it. This number is really a negative 0.00000000001, which is really, really close to 0. So even though it says this and you're a little confused by it at first, that's really just 0, like it is over here. All right, so with that you can see, I want to know, where is this parabola, where's this funny thing, where is it less, let's see, was it less than, greater than 0? Okay, I wanted to know where it's greater than 0. So you can see it's going to be greater than 0 here and here, which is again corresponding to these, and also for these x's over to the right over here, which would be to the right of 2.47. So I have this split interval again, and I can see that graphically.